Hey, good morning and welcome back. Today's lesson, we're going to talk a little bit about domain and the restrictions on this domain. So just to refresh our memory from a couple days ago, domain, remember, deals with our x value. Okay, now there's a couple things we're going to talk about, and they're related to some things we can't do in math. Okay, so one thing we can't do is we can't divide by the number 0, and we can't also take the square root of negatives, so square root negatives. Okay, and the first one we're going to talk about is, as we said, dividing by 0. Okay, we can't divide by 0. And another way to put this is we can't have the bottom of a fraction be 0. So that's the denominator cannot be equal to 0. So if we look at this first one, it says x plus 5 divided by x plus 3. All we care about is the denominator, and x plus 3 cannot be equal to 0. So if we subtract, x cannot be equal to 0. Or whoops, not 0. Sorry, 0 minus 3. So it cannot be equal to negative 3. So if we scroll down here, one thing I wanted to point out, when there are no restrictions, we can say that it can be all real numbers. These are all the possible values of x. And the symbol for that sometimes looks like an R with a line through it, or maybe the lines beside the R. So either of those are just the symbols for all real numbers. So to answer this question then, we would say it's all real numbers except x cannot be equal to negative 3. So on the next one, we do the same thing. X minus 2 cannot be equal to 0. So x cannot equal 2. And we could think about it all real numbers as long as x is not equal to 2. Okay, now our second restriction is the idea that we can't square root negatives, okay? Or get an imaginary number. So we can't square root negatives. So that means when we have a square root, whatever's inside it cannot be negative. So it must be, if we have a square root, it must be greater than or equal to 0. Okay, so if we look at example 3, x plus 2 is greater than or equal to 0. We'd subtract 2. X must be greater than or equal to negative 2. And that's our answer. Example 4, same thing. 3x minus 12 must be greater than or equal to 0. So 3x must be greater than or equal to 12. X has to be greater than or equal to 4. All right. On to the next one. The square root of this x minus 1. Oh, I forgot. If the square root is on the bottom now, we have something special. Okay, we already said the bottom cannot be equal to 0. Meanwhile, square root has to be greater than or equal to 0. So if it's on the bottom, no longer can be equal. It has to be greater than 0. Okay, so x minus 1 has to be greater than 0, so x must be greater than 1. Likewise, on this next one, 2 minus x is greater than 0. If we subtract 2, negative x is greater than negative 2. X, it switches when we divide by negative, is less than 2. At the bottom here, if we think about this, example 7, this would be a line. It goes forever in each direction, so it could be all real numbers. Okay, so we can either put just all reals, or if you prefer, you can put the symbol. Doesn't matter. Likewise, this would be a quadratic. It's going to go forever. Okay, so the same thing, all reals, or like that. On to the next. These are just review. I'm not going to look at 9. It's just like on the front. Number 10 here. All we do, remember, it's denominator, so we set it. It cannot be equal to 0. 2x cannot be equal to 3, which means x cannot be equal to 3 divided by 2. So all reals such that x cannot be equal to 3 divided by 2. Okay, the only difference, one last type of problem to look at. Here we have a quadratic on the bottom. Once again, it's a denominator, so we do the same thing. We set it so that it cannot be equal to 0. Then, in this case, we have to factor in order to solve. So we want two things that multiply to 24 add up to 11. So plus 8 plus 3. 8 times 3 is 24. 8 plus 3 is 11. Then we do x plus 8 is not equal to 0, and x plus 3 is not equal to 0. This results in x cannot be equal to negative 8. X cannot be equal to negative 3. So it's all reals such that those are true. And we can do the same thing for example 12. I'm not going to. If you need help, please reach out. Be happy to go through more examples with you. Hope you have a great day, and I'll talk to you later.